Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss another very important topic with respect to data engineering concepts, okay? And that is partitioning, right? So if you are using AWS Athena as serverless tool to query your big data, or maybe you are using Hive kind of data warehousing tool, then widely we use partitioning concept to improve the query efficiency, right? Now I am going to show you one particular concept related to partitioning which you must have to keep in your mind if you are working with this particular big data concept, okay? And without any further delay, let us directly jump into our lab section, and eventually I'll explain what we are doing and what we have to keep in mind while working with partitioning, right? So as a first step, what we are going to do, we are going to create a partition data. Let's first create that kind of data, okay? And for that, I am going to take help from Snowflake. So basically in Snowflake, I am going to create a table, and that table I am going to unload in our S3 location, okay, in a partition format. So as you can see here, our queries database if exists Ramu, I am creating that database, I am using that database, right? If you are having some existing database and you want to use that is perfectly fine. You can ignore these steps, just you can specify, use that particular database name you can provide, okay? And then here what we are doing, we are creating tables in it, okay? So book ID, book name, publisher, author, publish year, publish month. This is the structure, right? And here we are having some insert query. What we will do, while unloading the data from Snowflake to our data lake S3, we will partition the data based on partition year and partition month. Okay, and that is making sense also, right? Because partition we generally apply on such columns which are having low cardinality. That is basically lower number of distinct values. And based on year, month, day, these kind of columns generally in data lake we do partitioning, right? So that's what we are going to follow here also. So here we are having some insert queries. This complete code I'll be providing in the description box or in the comment section. So obviously you can take from there. Okay, we are having little bit good volume of data to experiment. And then here what we are doing, we can query the table. Okay, here for unloading purpose I am creating a file format. So as of now I am keeping it very simple. I am just creating a my CSV file format which is having a skip header 1 and type is CSV, field delimiter is comma, like that, okay? So this particular CSV file format will be using for unloading purpose. So here is our unload command. Copy into S3://. So here we can put the bucket or folder location where we want to unload the data as partition format. Then from select star from books. The complete data I want to unload, no filtering, no join, nothing transformations we are applying. And then partition by. Okay, very important point, how I am writing the partitioning code. Because that's how you have to write and that's how you should be doing partitioning. So first thing what I am writing, partition year equal to. Okay, so maybe suppose year equal to 2022. Okay, then how the partitioning will be created? So first this keyword year equal to will be there, and then the value will be there, and then after that there will be slash. Okay, and then here it will be having month, and then month equal to 4, 5, like that it will be there. Okay, and inside that actually our data will be stored. Okay, so always we should be using this kind of keyword, and after that we should be putting the value. So that same way I have given the expression here. Okay, partition by publish year equal to. Okay, then here I am applying string concatenation, very simple concept, and I am taking publish year. So this particular value will be dynamically taking for individual partitions while iterating in this particular result set. Okay, then we are appending slash publish month, that is this kind of a slash month, this part we are appending, and then equal to we are taking publish month as a variable. Okay, like that. I hope it is very simple. And then file format, we are specifying the file format whatever we have created. We want to keep header, and then here we are not creating any external stage or integration object beforehand. Okay, in the copy command itself, suppose I want to create those kind of connection in between Snowflake and S3, then here we can put credential in the copy command itself. Okay, AWS access can secret we will be putting here, as simple as that. Okay, right. So now what we will do, we will execute this one by one, but before that, first of all I'll be going to my AWS management console, and I'll be creating a S3 bucket where we can basically unload the data. Okay, so here I will create the bucket name is Snowflake unload Athena partition. Okay, some name I am giving, right? And then here what I will do, I'll create the bucket. Okay, perfect. So your bucket is there. I'll be copying this particular bucket name and I'll be pasting that here. Okay, and maybe inside this particular bucket in a particular folder I want to unload the data, and that folder name is unload partition. Okay, right, perfect. And then here what we need to do, we need to give AWS access key and secret key. So for that I'll be taking my root accounts access key and secret key. When we will go to production, that time you can fine tune the access physically, not a problem. After the experiment I'll be anyway deleting this kind of access key and secret key, right? So let's take that. So I'll be just copying the access key, okay, and here I'll be taking the secret key also. Perfect, right? So we are pretty much set. I will just take this particular code from the top and then I'll be copying this one and I'll be pasting that in my Snowflake new worksheet. Okay, right? I hope it is making sense to you. Now what we will do, we will first remove this one, and then here we will basically drop database, and then here we will create the database. We will use this database. We will be creating the table. We will be inserting the data. Okay, and here you can see that 1000 rows got inserted. Now if I do select star from books, here we will be seeing that data is there. Okay, now based on partition year and partition month, we want to partition our data. So if I go to our bucket, currently as of now nothing is there. So what we will do, we will basically create our file format. Okay, file format, my CSV file format successfully created, and here we are going to unload our data. Okay, in this particular folder location. So let's run this one. It is going to take some amount of time, and see, it is basically done. Here detailed results it will be showing. Right, now I'll go back to data lake. I'll be just refreshing this one, and here I'll be getting the folder location. Inside the folder, if we go here, see partition year, different partitions are created. If I go to one single partition, here based on month we are getting data. Okay, and inside the month, if we go here, we will be getting a CSV file. I can maybe download one and I can show you. See, here we are getting the data. Okay, see, if you observe very carefully, partition year and partition month are taking same value, 2004 and 10. Okay, so if you see the data what we downloaded for 2004 is partition year and partition month is 10. So whenever we will apply filter condition on partition year or month, then only this particular data will be queried. So that way we are reducing the scan area. Okay, and that way the query will be faster. That's what the theory says, at least, right? We will see that. So that's pretty much it with respect to partitioning. We have partitioned our data. Now what we are going to do, we are going to create an external table pointing to this particular partition data, whatever we unloaded, okay, in the bucket. So the code looks like this: create table, books, book ID, book name, publish year, publisher, and author. These are the 4 columns. We are not putting publish year and partition month in the DDL, because that is the concept of partitioning, that if you are applying partitioning concept, then on those columns on which you are applying partitioning, don't put those in this main DDL. Okay, so here we can write partitioned by, we are specifying the partition columns, and then here the row format delimited, header is there, all these kinds of stuff we are mentioning. So here in location parameter we need to paste the location. So where we unloaded, the same location our Athena table will be basically pointing to. I'll be just replacing that name here, and that's pretty much it. We are ready, right? So I will just copy this particular stuff and I will go back to AWS Management Console. And I can go to Athena. And then here database, as of now I'm choosing default database. I'll be just pasting this one. What it will do, it will create an external table books pointing to this particular location. Okay, so here what I will do, I will just run this one. Okay, give external keyword also. So here it is showing before you run your first query, you need to set up a query result location to S3. So where you want to store the query result, that we also need to specify, right? So I'll be going to settings and I'll go to manage, browse S3. So maybe we want to store all the Athena result in this particular bucket logga, and then here we will save this one, okay? And then we can go back to editor, and what we'll do, we will run this one, okay? So see, query execution successful. Here books table is created, okay? Here you can see it is showing partitioned, that is this particular books table is partitioned, okay? So here if you see the structure, partition year is basically one partition and partition month is another, okay? Now what we will do, we will basically query one particular specific select expression, what we have written here in Snowflake first, okay? So I'll go to Snowflake and here I will paste this one, and I am going to extract all those records which are basically having published year 2009 and published month is 20. We are getting 5 rows, right? And if you go to basically this particular query ID, if you click on this here, you can get some detailed explanation in the profile part. So total execution time is 43 milliseconds. This kind of data it is showing, right? So now I'll go back to worksheet. So the thing is 5 rows are there, right? Now we'll query the same from Athena, right? So here I will paste that in Athena, and then here what I will do, I will basically run this particular query, okay? Let's see what result we are getting. And the thing is, we are getting no result, okay? So what's the problem? Already we have created our data lake in partition format, right? And the Athena is pointing to that particular location only, but still if we are querying in Snowflake, we are getting the data but not in Athena, right? What is the problem? The thing is, here we have created the partition data, right? But Athena, Hive, etc. use the metastore concept. They are storing all the metadata in a particular server, right? That can be MySQL server, Darby database for Hive, that can be Glue, whatever, right? So the thing is, there it is not updated, okay? In the particular metastore, where all the metadata is stored, there it is not updated that these are the partitions what we created on this particular table. And that's why we have to execute one command, which is MSK Repair, okay? What is this command is saying? The command looks like this, MSK Repair Table book, okay? What it will do, it will basically repair the table, and if suppose some partition is present in data lake but our Athena is not able to take because it is not present in our metastore, then it will sync up the metastore, it will update all the partitions in the metastore so that you can query properly and get the accurate result, okay? This is very important point, and if you are using partitioning concept whether in AWS Athena or AWS Hive, you must have to use this one, okay? So MSK Repair Table book, I will just run this particular stuff, okay? And it will scan the whole S3 location where this particular table is pointing to. It will extract all those partitions and it will update the metadata metastore location, okay? So here you can see it will take couple of seconds. So whenever a new partition you are adding directly in data lake, you must have to execute this particular query so that from S3 it will be in sync with our metastore, okay? And then if we query this particular data, we will be getting a very fast way the result set, right? We'll see that. So first let's execute this particular query, okay? So here see, partition not in metastore. All these partitions are actually not available in metastore. So first it has detected all those, and then here you can see it is showing that added partition to metastore books, like that. All these partitions are now added in the metastore, okay? Now if we query this particular table, okay, with this kind of condition, we will be getting the result set is. See, 5 records are there. In Snowflake also we are getting 5 records, right? So here you can see the total runtime is 1.306 seconds, okay? Data scan 0.17 KB. So actually this scan area we have reduced due to partitioning, that's all, right? Now the thing is, here we have done it manually. MSK repair command we have added manually. But every time suppose new partition is coming, then you have to make sure this stuff is happening. So how we can automate the process? That's the question next. Okay. So what we can do, as soon as some data is coming in S3, we can trigger a lambda, and that lambda will execute this particular code in Athena, okay, using both of the connection. That kind of stuff we can do. And again, both of three, I have followed the documentation and I have written the code, no rocket science, okay. So how the code looks like? Simple, import JSON, import both of three. First we are importing the necessary stuffs, and then here comes our main lambda function. We are printing the event just for checking for which particular S3 data it is getting triggered. And here what we are doing, we are creating the client for Athena. Obviously your lambda should have access to Athena. And then here we are hard coding this particular query as of now, but you can improve this particular query, the MSK repair command. And then here Athena client we are using, and then start query execution. Okay, so this will invoke this particular query asynchronously. It is not like MSK repair is taking time to execute in the backend, lambda will wait. It is not like that. It will throw up the particular query execution, and it will give you one ID. Based on that particular ID, you can poll how in Snowflake asynchronously we call SQL queries, that same approach. But here as of now we are not doing that polling mechanism. I kept the lambda very simple. All we are doing, we are basically throwing up the query. Here we need to put the database name. Okay, so what is the database name in our case? Our database name is default, right? So I'll be putting that. You can put your database name and result configuration, where you want to store your result set. That particular S3 location also you have to keep here. Okay, so that one we have configured, right? In the settings, if we go, that is basically this particular location. I'll be copying that one, and here I'll be pasting that. That's it. Okay, and here our code is ready. So all we'll do now, we'll be going back to AWS Management Console, and we'll be creating a lambda function which will trigger MSK repair command as soon as some partition is coming getting created in S3. Okay, so here I'll be going to lambda, and here I'll go to create function name demo MSK automate. Okay, what is the language? I am choosing Python 3.9 as of now, and here I will create the function. Okay, perfect. I hope this is very simple to you, and I'll be providing all the codes also. So I will request you to practice all these concepts. Only seeing this video might not help you, because this is no rocket science, but you will be getting a good feeling when to work with which particular option if you have a good practice. Okay, and you can improve the code also. So that's pretty much it. Now I'll go to configuration, and I will go to this particular role, and I will update the access. Okay, I will add the Athena access to this lambda. Okay, that is our next step. I'll be going to add partition and attach the policy, and here I will go to Athena, search for Athena, and as of now I am giving Athena full access to this particular role, right? And that's pretty much it. Now what we'll do, we'll add the trigger from this. So bucket name is this particular one. All object create event is fine, and I acknowledge this particular stuff, and I will add this, right? So here our S3 trigger is created. Perfect. And our code is also ready. Access also we have given. So now what we'll do, we'll basically insert some more records in our Snowflake table, and again we'll unload the data, and we'll see whether this particular lambda is getting triggered or not. Okay. So here what we are doing, we are inserting some data for the year 20,300 and 20,200. Okay. And then we will execute only this particular select query, which will specifically select only those records whatever we have inserted here, and that record alone we will try to unload in our S3 location. Okay, so what I will do, I will basically take the copy command from here. Okay, and I will basically paste that here. All I will do, I will just change the select. Earlier we were unloading complete stuff, but because I have already unloaded some, so I'm just specifying based on filter condition. Okay, I hope you are getting it. Now I will go to insert query, and then here I will go to Snowflake. Okay, I'll paste this one, and I will run this one. Cool, 5 records got inserted. Okay, now here we will unload the data. Okay, so now if I do select start from books where published here is this and this, here we are getting 5 records. Okay, for the year 20,300 and 20,200. But if I go to our data lake as of now, here 20,200 and 20,300 data is not there, right? So now what I will do, I will just execute this particular copy command. Okay, so here's the 5 records. Okay, now I will go to our S3, I will refresh this one, and if I go here, see 20,200 and 20,300 folders got loaded. If I go inside there, based on partition month, the basically data got stored. Okay, now our Lambda should be getting triggered. So I can go to monitor section and I can go to view logs in CloudWatch. Okay, let's see the logs. So if you see our Snowflake here, actually 5 files got written like in our data lake. So that way 5 times 1, 2, 3, 4 and 5 times our Lambda got triggered. Okay, and in the back end obviously it is going to take some amount of time to execute that MSK query. Obviously it will return the query ID which you can hold to understand whether the MSK repair command is getting finished or not. If you go to CloudWatch, here you will able to see for which particular file or partition the Lambda got triggered. Okay, those kind of analysis you can do. Now what I will do, I will execute the same query from Snowflake to Athena and I will show you that this particular partition is also present in our Athena. Okay, I'll go back to editor and then here I will just go a little bit down here. Now whatever data we unloaded as of newly stuff, for them we have not executed this MSK repair command manually, but rather our Lambda is doing that activity, right? So I will just run this particular stuff to show you that 5 records exactly coming here. Okay, so see 1, 2, 3, 4, 5. Only 5 records whatever newly came, those are coming here. So why it is coming? Because we repaired the table using Lambda trigger. Okay, obviously this is a very simple Lambda code, but here it is having some disadvantage. Okay, like just for example, this particular code will not ensure that MSK Repair Table command is executed successfully or not in the backend. So that kind of preventive steps you can take. Okay, and again, suppose in S3 lot of files are getting written together, then for individual file the Lambda will be getting triggered, because S3 event notification will send individual event for each file writing in S3, right? So that you can optimize with SQS in the middle and specifying after how many event accumulation the Lambda should be getting triggered from the SQS. That kind of configuration you can add and improve the architecture. But just I wanted to show you this particular concept that MSK repair you must have to execute if you are doing some partitioning. If your source system is loading some partition in data lake but not via our Hive or Athena table, that time you have to execute this one so that your data lake and Athena or Hive metastore will be in sync. Okay, if you are creating the partition directly from the SQL query using Athena or Hive, then you no need to execute this one. But only if you are directly adding something in data lake, then Athena will not able to understand that that partition is added. That time you have to repair the table which will scan the complete data lake, that external location, and then it will update our metastore. Okay, I hope you understood this. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you are not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.